about complex numbers. The complex number minus 1 plus root 7i is denoted by u. Given that u is the root of the equation, find k. Okay, there are many ways to do this. This is how I would do it. So since we know minus 1 plus root 7i is a root, this means x minus that root is a factor. Now, if minus 1 plus root 7i is a root, minus 1 minus root 7i must be also a root, because it's the complex conjugate. So almost exactly the same, but instead of plus we use minus, the conjugate. It must be a root also. So which means this must be a factor also. So now we know that this is the equation, the original equation. We know that this is the first factor, this is the second factor, so the third factor must be some linear ax plus b. So to simplify this, open up the brackets, minus times minus, minus times plus, minus times minus, minus times plus. So now we have x plus 1 minus something, x plus 1 plus something. So this is the difference of two squares, a minus b, a plus b. We get a squared minus b squared. From the a squared, we get x squared plus 2a, x squared plus 2x plus 1. And from this squared, we get 7i squared. And remember, I squared is actually minus 1, which means this is actually plus 7. 1 plus 7 is 8. Now, we expand everything here. So x squared times ax, we get ax cubed. X squared times b, we have bx squared. 2ax squared, 2bx, 8ax, 8b. Now if we compare the coefficients, we know that 2x cubed is equal to ax cubed, which means the a must be 2. Now for the x squared term, we have 3 here, but this is b plus 2a. And remember, b plus 2a equals 3, but the a is 2, so we can find the b. Okay, so a is 2, this is 4, so 3 minus 4 is 1, minus 1. And from the x term, we have 2b plus 8a, and on top we have 14. So of course this means in case we want to check, minus 1 times 2, there will be minus 2. So we just plug in minus 1, and here we plug in 2. We're gonna get 16 minus 2, which is 14. So it checks we do have the right values of a and b. And now for the constant term, we know it's 8b, and we know the b is minus 1. So therefore the k is minus 8. Okay, so yeah, minus 8. Alright, so we have the value of k. Now the other two roots of the equation. So the first root is minus 1 plus root 7i. The other root must be the conjugate, so with minus, that's from the conjugate. And for the second root, since we know that the other factor is 2x minus 1, because the a is 2, the b is minus 1, 2x minus 1 is a factor. Therefore, just solve equals 0, we get x equals 1/2, which is the other root. Alright, now on an Argand diagram, sketch the locus. So z minus u, again the u is minus 1 plus root 7i, so z minus this guy. So for this kind of locus, we have the modulus of z only on one side. This is a circle. To find the center of the circle, just read this. It's got to be in the form of z minus something. So this thing would be the center, minus 1 root 7. And the radius is 2. And equal sign means we only use the circumference, we do not shade anything. So make a circle, center is -1 root 7, so yeah, root 7 is 2 point something, let's say around here, and the radius is 2, so the graph should be like this. We should have 2 y intercepts. So this is the graph. Now determine the greatest value of arc z for points on this locus. So this is from the previous part. Now the arc z would be a line from the origin to the circumference. So the line can be from origin to any point on the circumference. It can be like this, from origin to any point on the circumference. But since we are looking for the greatest value of arc z, that means we want the line to be touching this circle. So why is it touching? Well, because we need this theta to be as big as possible. So it is the greatest when this line is almost not touching anymore. So that's when this line is the tangent. So tangent means if we draw the radius here at the point of contact, it's gotta be perpendicular. So to find the z, we're gonna need to find either this angle or maybe this angle, and then of course we still have to add 90 degrees or pi over 2. So to find this angle, we can just maybe split it like this and look at this triangle first. So for this triangle here, so this triangle here, we have this distance, which is 1, of course, because this is from the center of the circle, which is at 1 minus 1 comma something. So this distance is 1, and of course this distance is root 7. Using Pythagoras, we get the hypotenuse, which is root 8. So we know that this length is actually root 8. Now if we look at this next triangle here, so from this triangle, we already know the radius of the circle is 2 previously, and we already know that the hypotenuse, the common side here, is root 8. So using Pythagoras again, we can find the other side if we want to. Now what we need is the angle. So I'm just going to call this angle alpha and beta. So this is the alpha and this is the beta. So to find the arc z, we just have to use 90 degrees, but in radians, so pi over 2 plus alpha plus beta. So to find alpha and beta, we can use inverse tangent or inverse sine or inverse cos. If we are using inverse tangent, we have to use opposite over adjacent, so 1 over root 7 for alpha. For beta, that's inverse tangent 2 over 2. Okay, so actually this one is beta and the other one is alpha. Okay, so just use a calculator and we'll get the final answer. Alright, I'll see you again next time.